Hello and welcome to the solution to the problem of the day posted on 8/7. Okay, after that very long setup we did, I think this should be very straightforward. We want to take the exterior derivative of this one form, right? So we act on it with the D operator. And remember, we discovered this thing called nilpotency, which means we don't have to treat this as a product to do the product rule. It's just simply the derivative of this zero form wedged with whatever's here. So we got this, and now we know what to do with that. That is the partial of x dx plus partial of x dy. This one is the same, partial y dx, partial y dy, wedged with dx. Okay, so let's write out what those are. So we've got the partial of x with respect to x is 1 dx. This is 0, and this is all wedged with dy. Partial y with respect to x is 0. Partial y with respect to y is 1, dy, and all that's wedged with dx. So we move the dx inside, so we get dx wedged dy minus dy wedged dx. Yes. We flip those last two, becomes a positive. So we got two of the same thing, so it's just 2. Now, part B was compare that to the curl of the vector, xey minus yex. Okay, so this is how we do the curl. So we're going to say all of these terms here are 0. This is the only one that isn't, so you cross this out, cross this out. It's this times that minus this times that. So that just becomes a 1. This becomes a 1, but it's negative. But because the way the determinant works is a negative here, so it becomes a positive. So it's just 2ez. So we've got, this is how it looks like in vector calculus, and this is how it looks like in differential geometry. And they are the same thing. And let's look and see why. Okay, now remember, we're in Cartesian coordinate system where the basis vectors for the vector basis and covector basis are equal, okay? So Ex equals dx, etc., right? So these are all, can be dx or ex, whichever you want, dx, dy, and dz, okay? And our problem is wedging dx with dy. So dx wedged dy is a counterclockwise move, which means a positive. So it's just dx. So it's just ex, right? And there's 2 of them. So it just makes that vector, which is 2 units long. And then we have 2 from this. We have 2 of these, right? Which is obviously the same thing. All right, I think that one was pretty straightforward. All right, see you later.